Hey guys, welcome to another video. In this video, we're going to tackle two questions about related rates. So let's get started. Suppose an object is moving along a path described as y is equal to x to the power 3. At t is equal to 5 seconds, the x value was 6 centimeters, and we measured that the speed on the x component is dx over dt, which is 4 centimeters per second. How fast was the object moving on the y component? So in this case over here, we have to understand that the movement of the object, the motion of the object, is describing the path x to the power 3. So if we derive the whole equation from left and right, we're going to get dy over dt equals 3x to the power of 2 dx over dt. And remember that it's always mandatory to multiply by the derivative of x in this case, according to chain rule. Now, a lot of the students, they would get confused because they will never utilize t is equal to 5 seconds. So sometimes you have to read the question very carefully because you might not need every single given information provided to you in that question. That doesn't mean you're doing anything wrong. So basically over here, we have the value of x, which is 6 centimeters, and we have the value of dx over dt, which is 4 centimeters. So it's going to be 6 to the power of 2 multiplied by dx over dt, which is 4. So this is going to give us 36 times 12, which is 432 centimeter per second. Now, in number 2, they asked us that water is leaking out a conical container at 8 centimeter per second. The cone's height is 24 centimeters and the radius is 9 centimeters. How fast is the water level falling when the water level is 10 centimeters? So basically we have, let's say, this amount of water in. The water level is going out, so it's leaking out. So the first thing that you have to understand is that the total cone's height is 24 centimeters. So you have to write all of your given information over here. So h equals 24 centimeter. We have that the radius is 9 centimeters. What else do we have? So we were asked to find how fast is the water level falling when the water level is at 10 centimeters. So if the water level over here is 10 centimeters, right? And this is going to be like our h, even though that the total h is 24, but at this instant, the h was 10 centimeters. They want us to find how fast is the water level dropping. So we want to see this piece, how fast is it dropping down, right? So basically what they want us to find is dh over dt. And we know that the water level is leaking out a conical container at 8 centimeter cube per second. That means that dv over dt is not just 8 centimeter cube per second, it is negative 8 centimeter cube per second, because the container, the conical container, is losing water rather than collecting water, if you want, or like filling it up with water. So they gave us the formula for the volume, which is pi r squared h over 3. It also can be described as 1 over 3 pi r squared h. Now, since they want us to find dh over dt, we have to focus a lot on the h component. So you can go ahead and differentiate this whole formula. Like this will be dv over dt, and this you will have to use product rule because r is a function and h is a function, so this is going to give you u prime v plus uv prime in this case. However, there's an easier method for you to solve such question. And how are we going to utilize this method? We are going to utilize this method by finding a relationship between r and h. See, the main objective over here, the main goal is to work with only h rather than R and H. How are we going to do that? So if you look closely, there is a relationship between the height and the radius, and it's literally right over here. So we know that the height over the radius is going to be 24 over 9. And 24 divided by 9, it is going to be almost 2.6. So we're just going to write 2.6 over here. So the relationship, if you cross multiply h over r equals to 2.6, you're going to get that h is equal to 2.6 r. But we want r in terms of h. So we're going to divide by 2.6 by 2.6. So r is going to be h over 2.6. So how is it going to look like? So right now v will be equal to 1 over 3 pi. Now instead of r, I'm going to replace it with h over 2.6. h over 2.6 to the power of 2, also multiplying it by h, which is going to give me 1 over 3 pi h to the power of 3 over 2.6 to the power of 2. Now, you can literally just multiply 2.6 by 2.6, and it's going to give you something close to 7.1. So let's erase over here, and let's replace it with 7.1. So now we accomplished our goal. We had r and h in our equation, but now we only have h, so it's so much easier to work with. It's so much easier to find the derivative for. We don't need to use product rule anymore. So when we derive it, we're going to derive this, okay, left side and right side. So dv over dt, it is going to be, the 3 is going to jump down, so it's going to be 3 over 3 pi h2 over 7.1 multiplied by dh over dt. So over here, I know what is h in this case, and they gave it to me as 10 centimeters. So, and I know dv over dt, which is negative 8. So negative 8 equals 3 over 3 is 1. So you're going to be left with pi. H squared is going to be 100 over 7.1 dh over dt. So this is going to be 7.1 times negative 8, which is going to be times 56.8. So negative 56.8 equals 100 pi dh over dt. So you're going to divide by 100 pi by 100 pi. So dh over dt is going to be negative 56.8 over 100 pi centimeter per second. You can leave it like this, or you can write it as a decimal point. But yeah, that's basically the question. So the only hard part about this question is actually figuring out the relationship between h and r. And the relationship is constant because the height is proportional with the radius. See, as much as the water level is rising, the radius is changing, because you know that a cone, the circle over here is going to be smaller than the circle over here, which is going to be smaller than the circle over here. However, the ratio of h over r is going to be 2.6 always. That's why we are able to get this information. That's why we were able to get this relationship over here. So yes, if you have any questions, please leave it in the comments. Thank you all for watching, and see you next time.